Hello students, welcome to the lecture on Business Process Engineering, and after the lecture we will be able to learn the following objectives. Define the motivation for adopting a BPM methodology. Differentiate the top-down versus bottom-up. Understand the business process engineering life cycle. Explain the business engineering framework process. Describe the principles of better business engineering. Let's start with the introduction. Traditionally, business processes were described using loosely defined graphical artifacts with users limited to supporting business analysis, discussions, and requirements. Definition for software projects. Today, a more rigorous business process modeling language can be applied and the graphical model extended to include IT functions to make it executable by an IT system. Furthermore, the operation of the business process can be monitored and analyzed by the Business Process Management (BPM) system to help the business to identify opportunities to continuously improve business processes performance. Automation has long been a goal of BPM, but until now, the tools for making a business process executable have been fraught with IT constraints and technical intervention. Only now it is possible to take a business process model, make associations with human workflow and IT applications, and place the flow of these activities under the control of an automated system without the need for specialized coding effort to tie it all together. In combination with the Business Rules Management System (BRMS) and Service-Oriented Architecture (SOA), modern enterprises can achieve the extremes of agility demanded by today's business environment. The zero-code approach to business process automation must be guided by an appropriate method designed specifically for the key BPM stakeholders, primarily business specialists, that also aligns with current IT environments and practices. The BPM methodology is an extension to well-established engineering practices designed to guide the implementation of business process automation and continuous improvement while supporting enterprise performance management (EPM). The BPM methodology is an agile strategy that defines an interactive approach to business process engineering highly suited to the rapidly changing business environment driven by market demands, mergers and acquisition, etc., and continuous incremental business process improvement. It is an adaptable strategy that complements existing software engineering practices and is compatible with common integration approaches. The following list outlines the benefit of using the BPM methodology as a foundation to create a standard practice for business process implementation for given organization. Predictability. By applying a consistent, proven approach to BPM engineering, the results and the cost can be determined in advance with a high degree of confidence. Business-driven, by identifying a range of well-known business motivation artifacts as drivers for business process identification and providing analytical feedback based on business-defined KPIs. The Oracle BPM method effectively ensures continuous alignment with business needs. Closing the business IT gap. The BPM method identifies stakeholder roles and their information exchanges at every step of the engineering process, ensuring effective business and IT collaboration. Process identification. The BPM method provides guidelines and tools for process computerization candidate analysis, leading to clear justification and measurable objectives for the BPM engineering project. This approach is also applied to business rule and KPI identification. Traceability. The method captures the key decisions and associated business. It is important to note that the foregoing list enumerates the benefits of employing a suitable method and supporting practices for the computerization and continuous improvement of business processes. It is not intended to describe the benefits of BPM or associated BPM systems. Can any one of you tell me why do we need an engineering method for business-driven activity of business process automation? IT organizations have become very adept at delivering reliable software engineering projects, although historically this was not the case. This change is due in part to the emergence and refinement of the project delivery methodologies that exist today. With an increased need for business and IT alignment and the enterprise scope of most BPM programs, the lessons learned in traditional software engineering must be applied to BPM. The plethora of software engineering methods in common use within IT tend to be inadequate for BPM because they are code-centric. BPM strives for zero-code implementations, are rarely model-driven, lack the steps necessary to effectively capture business process, overlook business key performance indicators. Instrumentation is typically an afterthought. Do not support continuous improvement beyond the planned iterations of the project. Lack vision beyond the scope of a single project. An effective method for BPM must address these inadequacies and support discovery of existing processes while encouraging cataloging and linking of related assets, separation of business concerns from technical concerns while fostering business IT cooperation. Part of that involves establishing a common language and understanding through techniques such as functional decomposition and process leveling. Business automation cannot be specified in a single requirements handoff or thrown over the wall to IT.
Business process management. Business process management is a process-centric approach for improving business performance. It combines information technology with governance methodologies. So what is a business process exactly? A business process is essentially a standardized way to convert a set of inputs into a desired output that a customer would find valuable. An example would be a loan application at a bank. The customer supplies an electronic application form, typically via the bank's website. This information becomes the input into the loan application process. The business process itself may then consist of a credit check and other activities that enables the bank to make a decision about whether to approve the loan or not. The output of the business process is a decision that is communicated to the customer, followed by the money being paid into the correct customer's bank account. We can say that the business process transforms several inputs into specific and more valuable outputs. In general, we can define the output of the process as everything that emerges from the process. The primary output is what is desired by the customer, in this case, the money they wanted to borrow. The secondary output is perhaps an email notifying the customer of the decision. The input to the process is provided by one or more suppliers. This is often in the form of information. The customer can be an internal customer like a manager at the bank, or the external customer who applied for the loan. Even another subsequent process can be thought of as a customer that is consuming the information created by the first process. Any entity that demands and consumes process output is considered as a customer. The three pillars of BPM is technology, people, and processes. All three aspects need to work for a BPM project to be a success. The business process needs to be fit for purpose and actually satisfy the demands of all the stakeholders. The people aspect also need to work. If the customer neglects to provide all the required information, the web page will alert him or her that the application form is incomplete. If a manager forgets to approve a certain process step, she will get an alert, and if she still ignores it, the alert will escalate to her manager, and the so-called process owner will also get an alert that the process is stuck. This level of visibility is impossible to achieve without good technology. For the automation to work smoothly, the information system needs to work seamlessly all of the time. It normally takes a large team of experts with IT and business knowledge to implement a BPM project. The project team will study a related set of business processes in great detail and then try to redesign it, with the objective of optimizing it so it is fit for purpose. This happens during the design phase of the project, where the processes are carefully designed to be as simple and straightforward as possible, so it can be completed in the shortest possible amount of time without making mistakes. During the modeling and simulation phase of the project, the process is documented in the form of an activity model. It is then possible to simulate the behavior of the system and try out different scenarios through a what-if approach. Once the process is approved by management, it is deployed. This occurs during the execution phase of the project. The project team will then monitor the performance of the business process to see if anything goes wrong. This is the monitoring phase. If any problems arise, changes will be made to further optimize the process to take care of exceptions. This occurs during the optimization phase of the project. A good BPM implementation will increase the visibility of the bank's activities, making it easy to monitor and control the critical business processes of the bank. It provides management with an increased ability to identify bottlenecks, make improvements where needed, and reassign resources to meet customer demand. It also provides an increased ability to identify further areas of optimization that will improve customer satisfaction or lower transaction costs. A good BPM system normally contributes significantly to reduced lead times, so the customer hears about the decision of the bank within days rather than weeks. BPM ensures better definition of the duties and the roles of the employees of the company. It's also a good tool for fraud prevention, auditing, and assessment of regulatory compliance. BPM system prevents the unfortunate situation where a customer who phoned to inquire about her loan application is transferred from one individual to the next and to the next, with all of them saying, "Sorry, it's not my decision, but let me transfer you to the person who deals with it." BPM uses a cross-functional approach, so the work is automatically moved from one desk to the next, without any need for manual intervention. Of course, training is crucial to ensure employees and managers know what is expected of them. Before a BPM initiative is launched, it is really important to get the buy-in and active support of senior management. The project leader needs to manage the expectation of all the stakeholders. Once the system is operational, the project is not yet complete. The team needs to listen to the customer feedback and make further improvements. In general, all the principles of change management needs to be followed to ensure success, because everybody's job will be a bit different after the project is done. Bill Gates once said, "The first rule of any technology is that automation applied to an efficient operation will magnify the efficiency. The second rule is that automation applied to an inefficient operation will magnify the inefficiency." It is important to remember that the information technology being used is simply an enabler that can take the business, its processes and management to new heights. It can create new, faster and more effective businesses if used correctly, but it can't fix broken processes.
Did you know The act of placing a business process under the control of a BPM system is called automation, not to be confused with automation of 1990s, which merely involved replacement of human tasks with computerized tasks. Coming to the next topic, top-down versus bottom-up. Historically, software projects were either driven by high-level business requirements top-down or by opportunities discovered in systems infrastructure and technological advancements bottom-up. Today, software engineering methods often recommend the benefits of a compromise between top-down and bottom-up, commonly referred to as meet me in the middle approach, example as found in the SOA Enterprise Technology Strategy. BPM, however, must be business driven, and a corresponding strategy top-down approach is necessary for the success of any BPM project. A bottom-up approach, while still valuable in the supporting infrastructure projects such as SOA service engineering, is unable to anticipate the needs of the business or even adequately identify enterprise-wide business processes. Taking a bottom-up approach is likely to yield, at best, only technical orchestrations or, at worst, distorted, unrealistic business processes designed to meet the needs of the application systems, not the business. Business users should be free to express business processes in the way that will most benefit the business and its customers, unencumbered by the constraints of technology. This mandates a top-down approach for business process engineering. The BPM methodology is a framework approach for the automation and ongoing improvement of business processes spanning original strategic analysis and process selection through traditional engineering lifecycle phases, technical design to deployment, and looping back via monitoring and process analysis. The initial phases of the methodology are particularly distinct from traditional software engineering, leaving the majority of this document focusing on business architecture asset identification, strategic analysis, business process selection, and business process identification and discovery. A number of related disciplines are referenced by this methodology but are not described in detail here since they are well established and documented elsewhere. These include business strategy planning and business architecture, business process modeling, SOA service, and other software engineering. Various business architecture and strategic planning artifacts, example, strategy maps, value chains, are identified as potential inputs through this document, but the approach for creating them is beyond the scope of this document, and most likely also those responsible for implementing BPM within an organization. But the approach for creating them is beyond the scope of this document and most likely also those responsible for implementing BPM within an organization. SOA service engineering can be found in the ITSO document software engineering in an SOA environment. While this methodology is intended to enable business process improvement, it is not intended to be a guide to business process improvement itself. Specifically, it may be an enabler for business process in re-engineering BPR, business transformation, or business process change management. However, these practices are not covered by this guide. Case management is a relatively new branch of BPM that is not yet formally defined. In fact, it does not even have a universally agreed definition within the BPM community. There are many software engineering methodologies available today, most of which follow the same sequence of analysis, design, implementation and deployment. In the case of a business process lifecycle, monitoring, while always present in the deployment operational stage, is critical to BPM. Deployment also plays a smaller role, although the traditional elements of testing, packaging, etc. must not be neglected entirely. The purpose is to emphasize the closed loop that is so important to continuous improvement in BPM. The business process lifecycle tracks the process from inception through retirement and includes its evolution through new versions created through each cycle of process improvement. This phase focuses on the business analysts and end users analyzing an as-is process and capturing the issues and challenges facing this process, that is, delays, disconnects, etc. A business process can be decomposed into several sub-processes which have their own attributes but also contribute to achieving the goal of the super process. The analysis of business processes typically includes the mapping of processes and sub-processes down to activity level. Once the issues and challenges have been uncovered, an improved to-be process is designed to resolve these issues. As part of the closed loop aspect of these phases, the second and subsequent iteration provides the opportunity to perform what-if analysis to determine whether or not the process could be enhanced by making changes in the underlying process, design and execution phases. This phase deals with taking the documented to-be process and translating it into a form that can be understood, implemented by systems. Traditionally, this has involved manual coding of each step of the process, but these manual efforts can now be minimized. BPM solutions have the ability to improve this phase by automating to varying degrees the input of process definitions, the use of tools which produce a graphical representation of the desired behavior and their translation into executable code. The new updated process and associated implementation infrastructure is brought together as a composite business application to be deployed, tested and promoted to production systems along with training for end users and IT. This phase is concerned with providing information for both the daily administration of business processes and long-term evaluation of process performance and effectiveness. Monitoring is based on key performance indicators established in the early stages of business process engineering. A dashboard presents a graphical representation of the status of executing processes, allowing business users to see detailed information about running process instances, enabling them to respond quicker to process bottlenecks that may be limiting overall business operation. The BPM methodology defines a number of states that the process must transition through in order to become an executable business process. Identified. The process has been selected for modeling and automated process management. Defined, refined. The business aspects of the model have been captured, modeled and refined to a sufficient level to support this iteration of process optimization. On the first iteration through this cycle, the identified process selected for automation undergo process discovery and definition. On subsequent iterations, the process, having been already defined, is merely refined. Designed. The technical aspects of the process model have been addressed, including integrations, message handling, interface specification, exception handling, security, transactions, etc. Composed. All external integrations, message wiring, and security roles have been configured. Tested. Any software engineering needed to support the process has completed and has been tested along with the process. Deployed. The executable process model and all external dependencies have been deployed into a production environment. Approved. Final QA approval. All testing and user acceptance has completed. Operational. The model has been commissioned and BPM system manages execution of the business process. Monitored. Process metrics are collected and provide actionable business intelligence. The business process engineering framework describes the approach to identify business processes, select those suitable for automation, and make them executable. Successful business process engineering ideally starts by taking business drivers from various potential sources of business motivation descriptions, including business plans, strategy maps, and associated value chains, etc. This approach enables us to identify core business processes and determine their business value alignment in the selection procedure. A tactical approach will also be shown later in the method detail sections that allows selection to proceed when access to these sensitive business documents is not available or in cases where business processes have been identified by some other means. In this activity, the selected business processes are subjected to discovery, in which many participants collaborate to agree upon a model describing the next level of detail for the business process as it is in its current state, that is, the as-is state. The process analyst applies further detail to the business process model, elaborating the model and resolving inconsistencies. This step also defines the project that supports the engineering activity for the business process or processes. The definition includes initial sizing of the effort involved in the automation project. Refinement refers to the improved version of the business process, also known as the to-be state, as this is where the process enters the cycle of continuous business process improvement. On entering the loop for the first time from the definition activity, changes should be kept to a level to strike a balance between the risk of over-ambitious change and demonstration of value through early wins. The next major activity in the engineering life cycle includes a feasibility analysis to ensure that the IT applications and systems are capable of supporting the automation as it is currently defined. A gap analysis is performed to specify requirements for extensions to existing IT capabilities needed to support the to-be business process model. Approved IT changes initiate software and service engineering projects separate from the business process engineering project. The business process application composition activity completes the technical steps necessary to make the business process model executable. This activity takes a white box testing approach to ensure the technical integration between the process engine and the underlying application functions, information services, and various other external data and systems performs appropriately. Deployment planning packages the composite business application and all its supporting software components and describes the procedures necessary to transfer it out of development. The package also includes operational procedures and end user documentation and training. Monitoring and analysis support both operational administration and management, OA and M, of the business process in the production environment and business process improvement. The analysis of data gathered from predefined key performance indicators, KPIs, provides critical information to the business analyst to support continuous improvement and continue the engineering life cycle by re-entering the refinement step. One of the primary reasons for putting a business process under the control of a BPM system is to enable ongoing continuous improvement of the business process. The Business Processes Engineering Project, abbreviated to BPM project, here is defined or identified by the selection of a process or processes suitable for automation. In this economy, it is difficult to imagine a management team that is not deeply absorbed in business engineering. After all, changing the shape of business is what management is all about. As it does so, consciously or subconsciously, it executes a business engineering process, the products of which are changes in some or all of the business's organization, culture, processes, or technology. The effectiveness of the process is measured in terms of changes in performance of the new business. Performance, in turn, is measured with metrics such as profitability, customer satisfaction, return on assets, growth, market share, and so on. It is this business engineering process that interests us. Unique among all business processes, this is the process by which management affects changes in business. We know there are many different forms of this process. A business improvement effort may be triggered by the installation or upgrade of a software system, a perceived quality problem in business performance, or hiring of a new senior executive. Although the explicit request may be simply to work on a software project, the analyst's scope often expands to include business improvement. Discrete Event Simulation (DES) can be described as a technique that is concerned with the modeling of systems in which the state variable, the collection of variables necessary to describe the system at any time, changes only at discrete points in time. It is in these points at which an event occurs, where an event is defined as an instantaneous occurrence that might change the state of the system. Discrete Event Simulation (DES) can be described as a technique that is concerned with the modeling of systems in which the state variable, the collection of variables necessary to describe the system at any time, changes only at discrete points in time. Now in the end, let us summarize what we have learned in this lecture. The operation of the business process can be monitored and analyzed by the Business Process Management (BPM) system to help the business to identify opportunities to continuously improve business process performance. Effective cooperation between business and IT is an absolute requirement and an ongoing cycle of improvement as the process evolves mandates a continuous dialogue. All these needs must be addressed by a BPM method. A bottom-up approach, while still valuable in the supporting infrastructure projects such as SOA service engineering, is unable to anticipate the needs of the business or even adequately identify enterprise-wide business processes. A number of related disciplines are referenced by this methodology but are not described in detail here since they are well established and documented elsewhere. These include business strategy planning and business architecture, business process modeling, SOA service, and other software engineering. BPM, maturity model and associated assessment and overall approach documents the process of this practitioner guide is the business process.